Morning, everyone. So today I'm going to blow your minds about why React is awesome. I started with React probably 4 or 5 months ago now, and I'm really convinced that it's a different way of building web applications. I really have not been that excited about a different approach before. A little bit about me before I get started. My name's Ginnivan. I work for Readify. I've spent the last 2 years in London working in the financial services space for a little consulting company called Adaptive Consulting. Most of my time there was doing WPF work, but now it's started transitioning a lot more into web. I do a heap of open source work, and you can contact me with any of those. I went to a conference in February called Code on the Sea. I don't know why someone hasn't organized this before, but the conference was held on the 2 sea days going to and from the Bahamas. And being a 2-day conference with 3 days of Bahamas in the middle, it was a reasonably relaxed environment to be able to just get to know the speakers because you're all stuck on a cruise ship, and just really flesh out problems, continue those conversations from the talks. One of the speakers, this guy, Rob Ashton, he's a little bit crazy. He's responsible for posts like "You ruined JavaScript," which managed to piss off a whole lot of people. And he was also the first, submitted the first pull request to MS Build, which deleted it and replaced it with make. That also annoyed a whole lot of people. He pretty much prides himself on being a professional troll, but he did a talk at Code on the Sea about how he builds web applications at his current client. And that was my first experience of React. He was really keen about it, and he's generally pretty critical about a lot of things. So after quite a few conversations over Mai Tais, like the one that's sitting, you might not be able to see, but there's a Mai Tai sitting on the stage there, he kind of convinced me that I should have a bit more of a look at this React thing. First, I just want to talk a little bit about the history of web UIs. We'll just quickly gloss over a little bit. But it started off with, say we just want to do a little to-do list, not very difficult. You reach into the DOM, find some element by its ID, and then append children to it. Really basic, but not very maintainable. But this is sort of where the interactivity with JavaScript started. We then got jQuery, which abstracted a lot of the browser idiosyncrasies and put a lot of hacks and things, just made all of that go away so we could just focus on what we needed to do no matter what browser we were using. The problem with that is you've got your HTML tags mixed in with your JavaScript. This is not very maintainable. So then we came up with templating libraries like handlebars, which up the top, you've got a handlebars template, which is this made-up language that allows us to express what we want to do. You've got basic control flows, so ifs and for each and those sort of things. And what template libraries basically do is you compile that template and you get given a function. And what the function does is you pass it your state, and it pretty much does string concatenation to replace all your variables and all of the markup in your template, turn that into JavaScript code that gives you a chunk of HTML. You then just put that back into the DOM, and now you're up and running. This has a lot of problems, though, because as soon as you replace a chunk of HTML, you lose the scroll position, you use what element was focused, all of these things that you'd expect from a nice, smooth web application. All of that just goes out the window. We then stole some ideas from WPF and started bringing data binding frameworks to the web, like Knockout and that sort of thing. This allowed us to separate our concerns a little bit better. All the data lived in some sort of view model, and then we declaratively said what we want where. So take this bit of data from my model and display it on the UI. That was a nice step forward, but all of these things are just incrementing. They're not really taking a new approach. We started seeing a little bit nicer approach with web components and directives that we can bundle this logic and the templates together, but it's still, once again, this is a little bit of an increment. They're just the same. React is a totally different concept. It's taking a step back and going, okay, what are really the problems we have with the way we build web applications? Where are our pain points coming from? And let's throw away all of the preconceptions about what a web framework looks like. Before I get started, I just want to touch quickly on ES6 or ES 2015 or whatever you want to call it. It has classes, but those familiar with JavaScript, this is just syntactic sugar. All my code is going to be using ES6 features, so I just want to make sure everyone's on the same page. All that is it transfers to just a function, and then that method on the class just becomes a method on the prototype for that function. Next, you've got arrow functions or lambdas. That's exactly the same as a function definition. The only difference is that a lambda does not have a new scope, whereas functions automatically have a new scope, and this changes. That's why arrow functions are really, really useful, and if you're doing JavaScript development, get into ES6 just because of the scoping problems that have been fixed. ES6 brings the concept of modules, so you can import some module. So here I've got import foo from foo. All that is using the node require syntax, just if you've used node before. You don't need to know all of these concepts. It's just if you're familiar with anything on the right, the left will make a bit more sense. And then finally, export. Files in modules have to explicitly export what other modules can see. So you've got this really explicit import and export at the file level, and files are completely, anything inside a file, it's completely isolated. So it gives you a really nice way of composing your JavaScript applications together. Not totally important for this talk, but just a little bit of a primer. So what is React? This is a React component. We'll break all of this down pretty soon, but you've got a few parts. The first part that you need to understand is state. React components can have internal state. They also have the presentation concerns inside the component. There's no separating those things into a template and the view model. It's all in one. So here I'm returning div input, an unordered list, and then I've got some JavaScript mixed in with this. So I've got an unordered list, and then I've got the list of the array of tasks, and I'm mapping it to another, like a list item. This looks pretty funky. The last thing is the event system in React. You can hook into events, and then they call back into your component. So there's sort of the three main parts. We'll go into these a little bit later. This freaks a lot of people out. As soon as you see this, it's like, whoa, you put HTML in my JavaScript. This is such a terrible idea. But the way, I saw a really good blog post, and I think this is the best way to describe it. JSX is the Weird Al kind of weird that's kind of awesome and probably better than the original. Not the Jar Jar Binks, really annoying, no one likes kind of weird. So what it actually is when you see each of those tags, all that is syntactic sugar once again. What it gets compiled down to is just JavaScript function calls. So when you see the div, that turns into react.createElement of type div. The next parameter is just a bunch of state that you want to pass to that component. And then finally, the children of the component. That's not very nice to write. No one wants to write that, and that's why JSX was invented. You can use the XML style syntax that you're used to, and you don't have to do all the balancing of all the parens at the end. The next problem is, oh my God, separation of concerns. You are mixing all of these concerns together. My application is not going to be maintainable, and it's just going to get us into a whole lot of problems. The thing is, markup and display logic, your views and your view models, they're actually really cohesive. Most of the time, you want to put something on your screen, you add a property or expose something from your view model, and then you wire it up. You change most of the time, you'll change both things at the same time. The logic or the code in both of those things are really cohesive, and they're tightly coupled. So what we end up doing is we're separating technologies just because our markup, the language that we have to display everything in is HTML, but HTML is not expressive. You can't do anything but static content, so you need JavaScript to make that happen. You've just separated two things that are tightly coupled, and it's just due to the technologies not being able to be put together. React reinvents that, so everything is JavaScript. There's a few things that when you start talking about everything is JavaScript, you start having to accept that templating languages just aren't expressive enough. There's this whole movement around we want to remove all logic out of our templates and just make them really, really basic. But all that does is our view models just end up having all of this logic that's about the display. So if we can't make simple decisions like, I've got one item in the list, I want to say item, or multiple, and say items, if you can't put that in your templating language, then you move that logic down to your view model and just bind that through. If it's all JavaScript, you can just do an inline if, and you can do exactly what you want. Each of these frameworks are inventing their own DSL to do data binding that's slightly different. You have to read the docs. How do I do a knockout binding versus an Angular binding? It's just a string that gets parsed and then into what you intend to do. Once again, if it's all JavaScript, we're used to JavaScript. We don't have to invent another language. We've already got a very capable one. You can do, the thing is, you can also, I've touched on this, you can do everything in JavaScript that you would want to do. And you also don't have to parse anything. I was having a discussion about performance and the implications of this approach. If you've got templates, what you're templating, like Angular templates or whatever, Angular has to read that, tokenize it, break it all apart, figure out what you have to do. This just is all JavaScript and it gets projected. And the framework doesn't force you to separate the concerns. It's up to you as application developers. So we'll go into React's design. This is a quote that often gets thrown around by Dijkstra. I'm not going to make you read it all, or I'm not going to read it all. There's only one part, which is, our powers to visualize processes evolving in time are relatively poorly developed. For me, this is about, you've got your initial application state, and then things are happening over time. We have a really hard time figuring out what the implications of changes of state are over time. This is why we suck at asynchronous programming and similar sort of problems. We like trying to simplify these things. So what React did is go, okay, web development 10 years ago was much easier. Everything was on the server. A request would come in, we would fetch our application state from the database or wherever it comes from, we throw it at our templating engine, and then we return the page. Really easy. There's no change of state over time, and everything's completely stateless. Next request does exactly the same thing. Game development also works in this way. Every frame, it just drops what was rendered before, gets the current state of the world, and re-renders, and does that 60 frames a second. Both of these models are really easy to understand and really easy to work with. So React pretty much said, yep, I just want to use this approach on the web for my front-end single-page applications. So you have your application state. React calls render, which renders your entire application. That then just gets pushed into the browser, and there's your application. You then listen to events. That could be the user typing, clicking to anything. Those events then mutate the application state, so you have a new application state, which then you re-render your entire application again. You just throw the old DOM out, and now you've got a new one. This is really easy to understand. It's also really good for testing, and say you want to do an undo stack. You just keep all of the different versions of the application state, and you can just go back. If anything goes wrong and you've got error reporting, You can just serialize the application state and send it to the server, and then you can rehydrate the entire application in the exact state it was at that time. There's a lot of advantages to this model. So we'll talk about how it actually does that. Because if we're throwing away your entire application every time, we're back in the template, the handlebars land, where we just cause a lot of DOM thrashing. Every time we rewrite the DOM, we lose the cursor position, the scroll position, we get jumping effects. It's really a terrible user experience. So we now know the way we want to program. It's now a technical problem we have to solve. And the way the React guys did is they introduced a concept called the virtual DOM. So instead of dealing with the real HTML DOM, they have a JavaScript object representation of the DOM. So let's say this is our DOM, and we have a virtual DOM, which is exactly the same. I want to remove the first item and then add a third item in. What the virtual DOM will do is, that is the new application state, that one's the old one. I'll do a diff of those two to find the differences. They'll then create a patch. And what the patch is I need to insert list item with key 3 at the bottom of the UL, and then I want to delete the list item with key of 1. That's the command that's going to be executed. React then applies that to the real DOM, and then it copies the new application state into the old version of the virtual DOM. And it just goes over this again and again. If the old DOM and the new DOM, like old application state versus new application state, is the same, the real DOM is not touched. And the DOM is incredibly slow in comparison to JavaScript. JavaScript is with V8 and all of these modern JavaScript engines, is really, really fast. But the DOM is still very in comparison. So now we've got a technique that removes the whole problem of thrashing and the templating libraries. And the other thing about this is it's really fast. Doing this virtual DOM diff is really, really, really fast. You can have massive amounts of virtual DOM, nested like tables and all that sort of stuff, and it's fast, sort of a couple of milliseconds. There is no problem diffing at 60 FPS on like an iPhone's browser. It's very capable. There's one thing I wanted to touch on that is often confused, is the concept of a shadow DOM. The shadow DOM is something that's coming around with the new version of new versions of the browsers and JavaScript, but it basically is the way elements are scoped. So here we've got an input which has a type of range. If you do that, you'll end up with a slider on your screen. But you can style the individual elements by targeting the slider element inside this range with CSS. So there have to be elements inside this that we can't see. If we go in and try and get the child element, it's null. That has no HTML elements under it. This is the shadow DOM working. The shadow DOM allows you to hide the inner HTML of a component, and you interact with the component itself. So input, the browse, all of these are just really leveraging the shadow DOM, which has been there for years. It's just not accessible to us. So the virtual DOM is one thing, shadow DOM is something else. Well then, I'm just going to do a bit of a demo and break React down so you can actually see all the parts of React. It's quite funny because React is such a small library. You can go over the entire surface area of the library in about 10 minutes. I wonder how much of the concepts you could actually digest with Angular, with transcluded directives and all of these words that they've invented. It's really, this is a very stark contrast. So let me just pull up Atom. How's that for everyone in terms of size up the back? Good? Excellent. Okay, so what we're going to do is we're going to build a really simple control, which is just a name that you can click a rename button. It'll change to a text box we then can either confirm the rename or cancel it. So I've got these are React components. These are the building blocks. So first thing we want to do is we have two React components. We have a name component, and then I've got a reusable, renameable text component. This is one of the patterns you end up finding in React, that you have something that's specific to your application, and then you pull out just generic reusable components. So the first thing is we have render. The render function is where we actually return what DOM we want rendered. This is now using JSX and the composition elements. I can actually just go renameable text and return that. So this is, you just create a React component and then you can compose that into other React components. With a lot of other frameworks, you've got templates and then you have to drop down into JavaScript to do your composition. That's the word I was looking for, that I used many times before. The next concept is you want to be able to pass down information. So here I just want to go text equals Jake. Now I've started the composition. I want to do exactly the same thing on this one, but now I need to receive the props. So I take a constructor that takes the props collection, and that's just the attributes on this renameable text get turned into a JavaScript object and passed down into my component. So inside the render function, I will return a div. And then I want to display the text. So I'll go this.props.text. If I jump over to my browser and refresh that, we should, when it loads. So what I've got here, just while that loads, is browser.js, and that's part of a transpilation tool called Babel, and that allows me to write ES6 inside the browser in a script tag, and it will get parsed, transpiled, and compiled as ECMAScript 5 that all the browsers can run. So now I've got Jake on the screen. Great. The next thing we want to do is we want to put a button, and I want to be able to click the button and it changes to a text box. So here, I'll just go input type equals text. That's right, isn't it? And actually, I want a button. And the value of this is rename. We're then going to introduce the next concept, which is the state. React components have state. And we need some sort of initial state. So that's going to be is renaming. It's false. I want to be able to transition my component to being in renaming mode or not. Now this is not doing anything yet. We just have an extra button. So what I want to do is when I click the button, I want to transition. I want to change the way my app is composed. So what I'll do here is just go on click. This is using React's synthetic event system. So you're not dealing with DOM events at this point. You're just dealing with React's eventing system. What React does at the root level of your application is it subscribes to all of the DOM level events, and then it just populates them down. So if you're familiar with WPF and the tunneling effect of WPF events, React pretty much uses the same technique. So here, I just want to go this.rename. So when I click, I want to invoke the rename function. When I do this, I want to change the state. So the way you change the state of a React component is with a function called setState. And this lets you provide the changes to the state. So you don't have to re-provide the entire state. It's just the state is an immutable collection, and when you call setState, it will update your component state based on what you've passed in. So if you don't specify that property, it won't be changed. It'll just be left. So here we go, is renaming, true. Finally, I want to use that state in the way this is rendering. So being JavaScript, I can just put an if inside my render and go this.state.isRenaming. Okay, so now if my component is in the renaming state, I'll just return a different DOM. And this allows me to transition between the two different modes of my component. So I'll just refresh that. And it's being really slow. So now I've got my button. If I hit rename, it blows up. So the reason for that is, being ECMAScript 6 and a prototyping language, the function doesn't belong to the instance of the class. So we have to go rename equals this.rename.bind this. It's a little bit annoying that you have to specify this. The previous version of syntax of React auto-bounds this. But that is black magic that they want to go away. They want you to actually explicitly opt into the way things behave. There are plugins to React that will enable things like auto binding, but we don't have that. So if we refresh that now, and I hit rename, we've now transitioned. And what's happened there is previously that was the virtual DOM that I returned, and then when I changed the application state, it called render again. I returned a different DOM representation. The diff kicked in. It then would remove the text and the button and put the text input in instead. So it updates the DOM in the most efficient way possible. We now actually can't type into this. I am typing, I promise. Because every time I'm typing, React is re-rendering, and the state is coming from the props, so what I've just typed goes away. So we need to now handle, once again, being able to type. So onChange is another event. These are well documented, very easy to figure out. There's not too many of them. So here I'll just go do a Lambda function. The E is the JavaScript event object, so when you type, it actually gives you the JavaScript object. So then I can just go, okay, I want to go this.setState. Remember before I said arrow functions do not get their own scope. This means you can use this inside an arrow function and be still referencing the outer object, whereas if you used a function, it would be a new scope, and this would be the function itself. So it makes it a little bit terser. So here I just want to go onChange text, or I'll say editing text, is e.target.value. So I'm just getting the value from the actual DOM element. I'll then add that into my state, and I will update this so it's pulling that from the state, editing text. I'll then need to, when I rename, set editing text to this.props.text. Is everyone following? We're all good? Great. So if I hit rename, I now am typing, and I've got, as I type, events being raised, I'm updating the state of my component, that then calls re-render, and the new text is updated. So it's this really, really nice flow. I'll leave that there, and I'll put the links to this up after so you can have a look. Whoa. Just a sec. Recording software slow. Okay, so we've broken React down a little bit. We've given you an idea of what the surface area of React looks like and how React components get composed together. The final part of the puzzle is when I want to finish the rename, when I hit confirm, I just pass a function down into that component that when I hit confirm, I just call back to the parent, so the parent gets notified that something's happened. And that's how React's data flow works. You flow props down, and then you call events back up the chain to get back to where you were. And this is quite a functional approach, and what ends up happening is a concept called currying in functional programming, where you use function calls to call other functions. So when my low-level renaming text component finishes, raises an event, which is renamed. So then the next level up is listening to that. So it adds more information to that, and then it raises its own event with extra information. So the information you lose when you're passing down less and less data to the lower level components, when you're going back up, you're adding that back in. And it makes, you don't have two-way data binding, which is a little inconvenient, but all of the data flow is really explicit. The next thing is, because you're dealing with components, the web community at large has sort of figured components are a really good idea. You can see that with the way Angular 2 is working. It's kind of getting rid of directives and controllers and things. They all exist, but they're all being moved into the context of components. The nice thing about that is, if you want to break things up and work with your designers, I've got my task list. That's a component there. I then have a second component. Then each of the items are another component. You end up breaking things and decomposing your app into so many more components than would be really convenient in these other frameworks, because when you pull things apart in Angular or Ember, and you've got to create new objects for the view, you have to bind up the templates. There's a lot of plumbing that goes involved with each time you decompose things. React makes it super simple, and it's one of the main drivers, I suppose. It makes it really easy to work with designers because they can look at the components in here, and most of the time, if you've got a designer, the component names will correlate to the different layers in Photoshop. So it has a lot of nice side effects. We've just done that. So the life cycle of a React component is the other part that's really interesting. So we saw that when I transitioned between the states, it removed the text and the button, and then I got the text box. What happens to each of those components is they go through different lifecycle events when they're being created or destroyed. So if we have a look at the initial render, we get the initial state from the constructor and the props. React will then call component will mount. This lets you know that the component is about to get mounted into the DOM. The next one is component did mount. You have been mounted into the DOM. This allows you to, if you need to focus or handle any events or something like that, you can do that because the DOM node's been created. Finally, when it's getting destroyed, you get told that the component will unmount. This is very handy if you're using something like RX or some sort of push-based that requires subscriptions or disposals or something like that, because you've got the point that you're about to be created, you can request from the server. When you're being destroyed, you can clean up anything. It becomes a really powerful model. You then have a workflow around properties changing. That's when name gets passed. You need to understand, the component needs to react and do something when new properties are being passed through. So you'll get told that the component will receive new props. It'll then say, ask the component, should you update? This is a really good performance optimization with React. If you're in Angular world and you're suddenly getting into digest loop hell, where it's just causing these recursive digest loops and your application is slowing down because you just have so many bindings and things, it's really hard to fix those performance problems. With React, at a point at your application that you could version your data, you can just check the version. Does the previous version of my data match the new version? And then if you say, that's the same, I don't have to re-render. React won't call your render method. It won't do the virtual DOM diff for the entire subtree of your application. It's a really simple and powerful performance optimization. It'll then tell you, once you've said, yes, it should update, it tells you, now your component will be updated. It'll then call render, and finally, after the render has been completed, it'll tell you your component has been updated. When the state changes, you call setState, and it goes through. Exactly the same, it's just missing the first component will receive props. A couple of other things. Styles. Styles are quite interesting. Because everything is JavaScript, we can no longer just do inline styles using CSS in the browser. So styles are actually a JavaScript object. In React, as soon as you see a brace, that's saying inside here is JavaScript. The second brace is creating a new JavaScript object. Then I'm using the key, and this is now Pascal case. So instead of background-color, it'll be background color with a capital B. All of that is normalized, which is actually quite nice because the browsers are reasonably inconsistent with CSS properties that have been added over time. And then on the right, it's just the value, so that'll be a string or a number or something. This allows you to compose styles, so you have base styles and just use JavaScript prototypal inheritance to then extend and mix in styles and do all of that sort of stuff. So you get a lot of the power that Sass and Less are giving you because we get all of that out of the box. We're already using JavaScript. It supports all of that. And then finally, you can just say class name is whatever. But we can also use, it has some nice helper methods. So you can just say, OK, I'll pass an array of class name, and then I will have a just inline if, which is if something's true, use the class 2, otherwise null. So toggling and those sort of styles and classes you can apply based on state become really, really simple to do. Another amazing thing that React enables that's not immediately obvious is the concept of isomorphic applications. And what that means is that your application runs on the server and the client. So what you can do with React is you're building it all up, but single-page applications, when you hit them, you get presented with this white screen because your entire application is in bundle.js or app.js. Has to download that, parse that, initialize your application, then render to the screen. That's not a great user experience. With React, you can just run this on the server side, fetch your initial application state, do your initial render into a string rather than to the DOM, because we're just giving React a representation of what we want our application to look like. So then we can project that to either the real DOM or just a string representation. So the initial render comes from the server using the exact same code and components that your entire client-side application is built with. Then app.js initializes, React bootstraps, your application starts rendering, it goes, there's a DOM there already. It looks a bit like a React DOM. I will turn the physical DOM into the initial virtual DOM. It then does a render loop of your entire application to get the current state of the application, then does the diff and brings the page that was sent from the server up to date with what's now running in the client, and now you're fully in the client. Quite a powerful concept. Testing. Initially, this sounds like this is going to be really, really hard to test, few things that make React really, really simple to test is they've got a concept of shallow rendering. So you can render a component to a test renderer, and then you can assert that certain elements exist. So if you want to test your navigation between different pages, really easy. You just say, okay, if my URL is this, then this other component should exist when it's rendered. Makes it really quite easy to do state-based testing. And because everything's JavaScript and React is kind of the view layer and doesn't impose services and all of this other stuff, the rest of it's JavaScript. So the entire rest of your application, all your application logic is just in JavaScript classes. Finally, I'm just going to show you a quick demo of an application I built with the guys I was working with in London. Okie dokie. So this is an application called Reactive Trader. We built this as a demo for how to build a responsive RX reactive style application where we're streaming prices to the client. This is a typical sort of app you'd see in finance. So each tile represents a currency pair of this is US dollar versus Japanese yen, and you can buy or sell one currency against the other. This is all using React. We originally built it using TypeScript and Knockout and in a way we'd be familiar with when working in the Microsoft way. This is reinventing it using Webpack and React and sort of more up-to-date JavaScript libraries and techniques. So you can see here, this is actually the structure of our application. We've got the main component, which is everything. We then drill down, and we've got a few classes that really don't matter, and divs and bits of layout and things. And then here I've got the spot tiles. So we can clean a lot of this up, and this gives you the idea of the component-based model where you have logical chunks of your application which then return bits of the DOM. And you can continue drilling down. So we're viewing the React's virtual DOM here, and then you've got the real rendered application. So I'll put the link to this, and this is worth diving into because it shows you how a React application will scale. With this, one of the things we wanted to prove is how well React would perform. And you can get this ticking sort of 50, 100 prices a second with no impact to performance. CPU usage goes up a little bit more, but yeah, it's quite impressive, the performance characteristics you can get out of that. That's the link there. It's under Adaptive Consulting. It's called React Adaptive Trader. Any questions? Hope that was a bit of a lap around React and why I think it's quite different and quite revolutionary. So any questions? Yes. Yep, so the question was about caching. You'd use all your normal techniques for caching your JavaScript files and your application. What's being served from the server would be the same techniques that you'd use on a server-side rendered application. And then the content that would be served, your app.js, you'd have some sort of cache-busting like query string on the end of it to make sure that the new version of the application was pointing at the right version of your app.js. But it should be pretty much the same techniques, that none of this should impact at all. Anything else? Cool, I'll let you guys go. Come grab me after. Thanks.